So often we want to visualize multiple variables simultaneously. And so we generate stacked graphs that can display several variables changing along the same dimension. For a bar chart, we may want to look at more than just a single quantitative dependent variable measured across an independent variable dimension. One way of doing this is with a stacked bar chart. In this case, we can have two or more dependent variables plotted. In this case, the blue bars are representing one dependent variable, and the red bars are representing a second dependent variable. And so we're using hue to represent different nominal value. Basically, the second dependent variable is different than the first dependent variable. And then the total amount of the contribution of both variables is represented by the height of these bars, of the top of these stacked bars, and the relative proportion is being represented by the proportion of the bar being one color versus another color. If we want to emphasize that relative proportion, we can have the bars stacked to 100% and just plot the percentage of the contribution of one variable versus the other variable as the difference in the colors of the bars. This kind of relative contribution is also represented in a pie chart. But in a pie chart, you're representing the contribution based on angle and a little bit by area than on position and length. Here in a pie chart, the relative proportion of the blue category versus the orange category versus the green category versus the yellow category is being represented by the angle as the angle sum to 360 degrees. It's also proportional to the area represented by each of these four regions. That indication can be degraded somewhat if you try to show a pie chart in 3 dimensions. And that's because in 3 dimensions, we're still perceiving a 3-dimensional scene as a 2-dimensional image, and the visual cues we're using include foreshortening and perspective, and those cues can get in the way of our ability to perceive a region, say, in the foreground as being larger or smaller than a region in the background, because of our expectation that perspective is going to make regions in the foreground larger, or at least appear larger, and regions in the background appear smaller, even if it's just an orthographic non-perspective projection. So it's best not to use 3 dimensions for pie charts. And in fact, it's better just to use a stacked bar chart instead of a pie chart. In this case, each one of these bars can represent a separate pie chart because it's representing the separate relative contribution to the whole of multiple dependent variables as they vary across some independent variable. Also, stacking order matters. I've got the same data plotted in the left and in the right. In the left, I've plotted the blue variable first, and then I've stacked the red variable on top of that. On the right side, I've plotted the red variable first, and I've stacked the blue variable on top of that. On the right, it's easy to see that the red variable isn't changing across the horizontal axis. On the left, you can still see that the red variable isn't changing, but you have to see that because the lengths aren't changing, whereas on the right, the actual positions aren't changing, which further verifies that position is a stronger indicator than length of the actual data values in terms of mapping to geometric and spatial display elements. You can avoid that stacking order problem by using diverging stacked bar charts if you have the red variable creating bars growing upwards and the blue variable creating bars growing downward, but that stops working when you have 3 or more variables. Another way to avoid having one variable dominate the other in stacking order is to stack them and then recenter the bar across the horizontal axis. So instead of growing up from the horizontal axis, the bar is just centered at the horizontal axis, and this gives us the same displacement on the top and the bottom of the bar chart, but it helps us to pay more attention to the areas of the elements instead of their actual position. It's much better if you have continuously changing horizontal and vertical axis variables to use stacked line graphs than stacked bar charts. If we can connect our data values by lines instead of having them discrete bars, then it's easier to see when areas are changing versus areas are remaining constant as they move across, even though they're displaced by the variance of other variables.